Hello everyone. This video will guide you through object-oriented programming in Python. I'll walk you through how to create classes and how to create objects and how to implement code using object-oriented programming in Python. So if we'll talk about what is an object-oriented programming is a programming paradigm based on concept of objects. The object contains both data and the code. So basically, in an object, we bind the variables and the methods together. It is object-oriented paradigm is to design the program using classes and objects. Now, there are many advantages of using classes and objects in programming, and I'll walk you through. Let's first understand what does it mean by class. So, classes allows us to logically group our data and function in a way that it is easy to reuse and a way to build upon if need to be. It is a blueprint or a template from which specific objects are created. So basically we say that classes are blueprint from which you can create objects. So for example, if we'll see in this picture, what you see here is three houses, and above these three houses, there is a floor plan. So this floor plan serves as a blueprint. Means if you have the floor plan ready, you can follow that floor plan and can build as many houses as you want. Okay, so the floor plan act as a blueprint, and the houses that you see here will act as objects. So if we'll say what is object, object is the instance of a class. Okay, so for example, this is first object, the another house that you see is another object, the third house that you see is another object. So object are instances of a class. And again, if you'll see, this is a floor plan. Following this floor plan, you can create as many houses as you want. So that means I am reusing the same floor plan again and again, right? Similarly, when we write a code, the class will logically group the similar entities together, and it will act as a template from which you're going to create many more objects. Okay, so one template and many objects from that template. That is why we say that we can reuse the code again and again. And this code reusability is the advantage of using this approach. So the first advantage of using object-oriented programming is code reusability. Okay, let's see other examples. Okay, so for example, here in this picture, I have an architecture of a car. Okay, a model of a car, let's say. So if I have this blueprint of a car, I can make many other car models from it, right? So if I have a blueprint ready, I can make Mercedes, BMW, Audi, etc. So this car will be called as a class, and Mercedes, BMW, Audi will be called as an object. Okay. Now, every object or every class has some properties and methods. Okay, an object binds that properties and method together. For example, let's consider this example. Now, in this example, as you can see, in this example, okay, it says that a class defines attributes and behavior. So what would be the attributes or properties of a car? A model, a car will have a model name, a car will have a year, it will have a make, right? So this could be attributes of a car. What would be the methods of a car? Car starts. Car, you can stop a car by applying brake. Car accelerates, right? So if I'll talk about a car class, a car will have a year, make, model. Year means the year in which it is manufactured. For example, it is manufactured in 2023. Make and model. Make could be BMW or Mercedes or Tesla. Model will be the model name, like Tesla has Model Y, Model X, something like that, right? So these will go towards the attributes of a car, and the properties will be attributes or properties, and methods will be start, stop, accelerate, etc. Okay, and the names Camry or Benz, Sonata. Okay, I know these are all the old models, but yes. So whatever is the different type of car will become your object. And if you'll see all these objects like Benz, um, like Audi, um, you have Tesla, all these cars, they share the same attributes. Like every car has a year, make, model, every car starts, stops, and accelerate, right? And there are some additional features which we'll see later. But as I said, a car serves as a blueprint and it logically groups the similar entities together. So I'll have a template of a car which will have a attribute as year, make, model, and will have a method as start, stop, and accelerate. And all these objects will have that attributes and that methods, right? That is the whole concept of classes and object. Basic advantage is the code reusability. Okay, so through classes and object, through object-oriented programming, you can reuse the code again and again. So for example, let's say these are the objects of class car. Okay, it has a make, model, color, all the attributes go towards the methods. And again, start, break, accelerate are the methods of this class. Similarly, if I'll make a class person, think what would be the attribute of a person? A person has a name, right? So a person has a name, age, gender, right? So, and yes, name, age, gender, city, address, phone, email, those are all the attributes of a person. What would be the methods of a person? A person eats, okay? Person sleep, person run, something like that. So it walk, eat, run, sleep, play, study, etc. Methods are generally verbs, okay? So this will be the attribute of a class person. And if I'll create an object of a class, let's say he's the object of the class, okay? So the name is John, age is 25 years old, gender is male, city is, let's say, Chicago. Similarly, I have another object of a class, Tia, 29 years old, female, and city is New York, right? So you see how we can relate a class with the objects. Objects is the one that binds the methods and the attributes together. Okay. So every class, as I said, will logically group the similar entities together. Okay. So this is the example of a class, an object. Now, how do you create a class in Python? Okay. Now, in Python, class uses variables to store data fields and define methods to perform action. A class can be defined using a keyword class and then followed by a class name. Okay, it will have a initializer. Initializer is designed to perform initializing actions such as creating the data field of objects. Now, we also use a self parameter with classes. It is required in every method of a class. Okay, you should stress on this. You should remember this. The self parameter is required in every method of a class. When a method executes, it must have a way of knowing which object's data attribute it is supposed to operate on. And that's where the self parameter comes in. Okay. When method is called, Python makes the self parameter reference the specific object that the method is supposed to operate on. Let's understand it with an example. Okay, let's try to create a class and let's understand it with an example. So I'm going to use Spider here. Okay, but the things work similarly in any IDE. So as I said, you will have a keyword class and you will have a class name, right? So class, and then the syntax is you write class, you write a class name, right? Colon, and then you write the initializer, right? Okay, let's try to understand this with an example. So I'm just first gonna comment this. Okay. So let's say I have a class cell phone. Okay. I have a class cell phone. So I'll have class name, and I will have an initializer. And the way you write an initializer is def underscore underscore init underscore underscore, okay, self. Okay. So initializer is basically similar to what you call constructors in other programming language. Okay. Now, if you will notice here, I had written that the self parameter is required in every method of the class. Okay. So this is the self parameter that I was talking about. So in every method that you write inside the class, it should have a self parameter. Now this one that you see over here is init, which is called as an initializer. It is not like a normal method. We call it as an initializer, which is responsible for creating the object. Okay. So for example, herein, now every variable that you're gonna write it over here, you're gonna say self dot. So if we'll say, if we'll talk about cell phone, what will be the attribute of a cell phone? It will have a manufacturer, a model, and a price, right? So I'm gonna say manufacturer. Okay. It will have a manufacturer. It will have a model, and it will have a price. Okay. Okay. So this will serve as a constructor. Okay, if you have learned constructor in other programming language, or you can say that initializer is basically responsible for creating the object of the class. Okay, now when you create an object of the class, what you can do is you can provide the values while creating the object itself. So herein I will provide the manufacturer. Okay, I'll provide the model, and I'll provide the price. Okay, and I will say that self.manufacturer equals to manufacturer, right? Self.model equals to model, and self.price equals to price. Okay, now when we create an object, we are going to supply these parameters. Okay, and this is how it will be linked through the initializer. Now, after this, so this one that I have written over here, we call it as, I'll just write it over here, initializer. Okay, and it is used for initializing the objects. Okay, now let's say I have to write some methods inside a class. Okay, so I'll call it as instant methods. Okay, and now every method that you write over here preceded with a def keyword, and whatever method you write inside a class, you write a self keyword inside it. Okay, so that when you create an object, your machine or your interpreter is going to bound that object with this method. Okay, and what I'm going to do is I'm going to print the names. Okay, so I'm going to make use of f string. I'm going to say manufacturer and this, and inside I'm going to say self dot manufacturer. Okay, so everything that you want to print, you're going to precede it with a self keyword. Okay, then I'm going to take /n. /n is for taking the cursor to a new line, model, and I'm going to say model, again, self dot model. Okay, /n, manufacturer, model, and price. So I'm gonna write it here. Okay, So if I'll see, it would look something like this. Okay, manufacturer. Okay, it is giving me an error, undefined price. And where? Okay, oh, self dot price, my bad. So self dot price, right? So what did I did? I created a class. This class has attributes, manufacturer, model, and price, and it has a method, just one method, that is show info. Okay. Now, how do we create an object of a class? So I'm gonna print. I'm gonna say I'm gonna just say cell phone info or cell phone information. Okay. And to create an object of a class. So how do you create an object of a class? To create an object of a class, you write an object name. So the syntax is write an object name equals to, you're going to write a class name. Okay, and same thing you're going to do here. So what I'm going to do is I'm going to create an object. Let's say my first cell phone is iPhone. Okay, and then my class name is cell phone. Right, my class name is cell phone. Now let's put the values inside. Okay, so this values should match with this sequence that you have provided. Okay, and that because that's how the data will be bind. So herein, I'll say my manufacturer is iPhone. Okay. Then model. So let's say 13 Pro. Okay. And let's say the cost is $900. Okay, the price is $900. So this has created one object of this class. Okay, so if you want to print it, this function, this method or function, I have written to print these things, right? Manufacturer, model, and price. So what I would do is to call any method from a class, you use a dot operator. So I'll say object name dot the function name. My function name is show info. Okay, so now see, when I run this code, it is showing what you have written in the show info method. Okay, so it is saying manufacturer is iPhone, model is 13 Pro, and price is 900. Okay, so what does it do? When you create an object here, okay, what happens internally in your computer? Okay, so what happens internally in your computer is an object is created, something like this, or you can say a memory space is allocated, okay, in your computer. Then you will have the name of the object as the name of your object. Okay, so my name of my object, this name of my object was iPhone. Okay, then all the attributes and the methods are inside that object. Okay, so what was my this thing? Attributes manufacturer. I put the manufacturer as iPhone, right? I put the model as 13 Pro, right? And I put the price as $900. Okay, and then you also had a method, right? What was the method? The method was show info. So this kind of structure is formed inside your computer. Okay, and what is the show info shows? Show infos will bind these things, manufacturer, phone, and model, and it's showing it on the screen, right? Now, so manufacturer, okay. So manufacturer and iPhone model, whatever I have written, 13 Pro, and price is 900. Okay, now when you have to access the attributes, you say the object name. My object name is iPhone, right? So what I would do is outside the class, I will say my object name. If I want to access the attributes, I'll directly say manufacturer. manufacturer. Okay, or iPhone dot model. If I have to access the method that is show info, I'll say object name dot show info. Okay, so whenever you have to call a function, you write it as object name dot function name. And same thing goes here. Okay, now you can create as many objects as you want. Okay, let's print another object. Let's say I'll print another object. Let's say second object is Samsung. Okay, and I'm gonna say again the name of the class and my object name, my manufacturer is Samsung. Okay, and let's say the model is Note 10, or I do not know what is the latest model, but I'll say just Note 10, and let's say $1,000. Okay, now I want to print it. Now you can directly print it by calling like this. Okay, you can do it like this as well. Samsung dot manufacturer. Okay, manufacturer. And it will print the manufacturer, which is Samsung. Okay, but many times these fields are not accessible outside the class, which we're going to see in a bit. Okay, so this is not a good practice. The good practice is you access it through the functions or through the methods of a class. So how do you call a method of the class again? Object name, which is Samsung dot show info, and object name dot show info. Okay, and whenever you're calling a function, it should be followed by parentheses. Okay, now see, let's run this code. And now you see, so both these cell phones information is being printed here. First one is manufacturer is iPhone. Second one is manufacturer is Samsung. Okay, so that's how the classes and objects work. Now, instead of providing the parameter here, you could have also asked the user. Okay, so for example, I'll get these values from the user. So I'm gonna say manufacturer equals to input. And I'm gonna say enter the manufacturer. Okay, similarly, I'll say enter the model. Okay, so herein I'm say enter the model, and herein I'm gonna say enter the price. Okay, and herein I'm gonna say enter the price. Okay, well, you can use other variables as well. You don't have to use the same variables. Okay, it works with the other variables as well. And here, and instead of providing this as phone and all, I will provide what is being asked from the user. So for example, I'll say iPhone equals to cell phone, that is the name of the class. And instead of manufacturer, I will provide this variable, which I have asked the user to enter. Then I'm gonna provide the model, and I'll provide the price. Okay, and then I'll say iPhone dot show info. Okay, now let's see. So I'm gonna comment this for now and this. Okay, now see, run the code, and it is asking me to enter the manufacturer. I'm just gonna drag the screen over this side. So it is asking me to enter the manufacturer, and I'll enter the manufacturer as Samsung iPhone I've already used, and let's say Nokia. Model, well, I'm not sure which model is, okay, 1800. And let's say price 500, okay. And see, manufacturer Nokia, model is 1800, price is this, right? Because I called show info. Okay, so I hope how to create classes, how to create objects is clear to you, right? Now, this is all object-oriented programming, okay? Now, object-oriented programming has 4 pillars, and this is a very common question for interviews as well, okay? And they are encapsulation, abstraction, inheritance, and polymorphism, okay? So, Object-oriented programming. Now, you're going to learn this in advanced Python. I'll just walk you through the basics of it. So, OOPS concepts, we have encapsulation, abstraction, inheritance, and polymorphism. Okay. What you have seen just now, that we create an object, right? And what does an object to do? Okay. The object, what does an object do? Object binds the attributes and the methods together. This is called as encapsulation. Okay. So let's see the details. Okay. So if I'll talk about an abstraction, abstraction lets you focus on what the object does instead of how it is done. The idea behind abstraction is knowing a thing on a high level. So abstraction means to represent the essential feature without detailing the background implementation of internal working details. Okay, so for example, when you see a phone, okay, you do not know what is inside the phone. You just know how to operate the phone, right? You do not know the internal implementation details, right? How does the phone work, or what happens when you type in on the keyword? You do not know those details, okay? That is called as abstraction, representing the essential features without detailing the background implementation or internal working detail. Okay, for example, when you drive a car again, okay, so when you drive a car, you know when you move the steering, the car will go left, right. When you press the accelerator, it will go forward, right? But you do not know the internal implementation details. Okay, so that's what is abstraction, representing the essential features without detailing the background implementation or internal working detail. Okay, now if we'll talk about encapsulation, okay, and by the way, why we do not want to show the internal implementation details? Okay, why what is the need of hiding that? Because if you give direct access to the internal implementation detail, a user might mess up with the whole code or the implementation of the system. For example, here in the picture, if you see, this person is riding a bike, okay, and instead of giving brake to the user in the bike, if he is trying to stop the bike with a rod by just putting, if he's trying to apply a brake to the bike, or if he's trying to stop the bike, he'll just put a rod inside the rim of the tires. What would happen? He will fall down, right? And that is why you do not want to give direct access to the internals of the system. Okay, that's the reason why we want to hide the details. Okay, implementation details. So when we talk about encapsulation, it is like a capsule, okay, wherein you put everything, like a medicine capsule of medicine, wherein you put everything inside the capsule, right? So similarly, encapsulation is binding the data and the behavior together in a single unit. Encapsulation is all about exposing a solution to a problem without requiring the consumer to fully understand the problem. Okay, and that is what is it to mean by encapsulation. It is just that you are hiding the classes. I'm sorry, you're hiding the methods, or you're encapsulating the methods and the variables together in an object. Okay, that is what is encapsulations. It is achieved by using access modifiers, which are of three types, like private, public, and protected. And it is also achieved by using mutators and accessors. Okay. Well, it is also called as data hiding. This is also a way that you can hide your data. And again, as I showed you, that what is the need of hiding your data? Because you would not like to give access to your internal system. Okay, you would like to protect your code. So encapsulation is not about just hiding complexity, but conversely exposing complexity in a fail-safe manner. It facilitates data hiding, thus also called as data hiding. It is achieved by access modifiers, which are private, public, and protected, which we're going to see in a bit, and by using mutators and accessors. Okay, so let's see what does it mean by access modifiers. Access modifiers limit access to the variables and methods of a class. Python provides three types of access modifiers, that is private, public, and protected. Public is accessible anywhere from outside of class. Private member is accessible within the class, and protected member is accessible within the class and its subclasses. Okay, let's see it with an example. Okay, so herein we had created this car class, right? Okay, so for example, herein, okay, if I want to have access to this manufacturer, okay, what I would do is let me just comment this out for now. Okay, so let's say my code is this much, wherein I have this code. I created a cell phone which has the manufacturer, model, and price. I asked the user, I created it. Okay, now instead of using show info, okay, what I would do is I will have access through the object name. So I'll say print. Okay, so I'll say print iPhone dot manufacturer. Okay. Okay, let's run this and check whether it prints the manufacturer. Okay. Okay, it is okay, where is it? Yeah. It is asking me to enter the manufacturer. I'll just say iPhone. Okay, enter the model 10, price, let's say 500. Okay, and it is printing the manufacturer. Right. So that means I have access to what is written inside the class. Okay, the variable that is written inside the class. So this variable is public because my class is ending here. Okay, at line number 14, what I have written over here is outside the class. Okay, so now I can access the variables that are written inside the class outside the class as well. Okay, that is called as public accessibility. So herein this variable has its accessibility is public. Okay, now to make it as private, okay, if I'll put it like this, okay, if I will put an underscore, one more underscore, okay, where did I did it? Okay, if I'll write it as underscore underscore, okay, underscore underscore manufacturer, this means now its accessibility is limited. In it, it cannot be accessed outside the class. Okay, let's see this. Okay, and herein also, when you make it as private, herein also you'll have to make it as private. So to make it as private, you use two underscores. Okay, now see, if I'll write it as iPhone dot manufacturer, am I able to access it? Let's see. So now again, I'll put a manufacturer as iPhone and model 10, price 900. And now see, it is giving me an error. Cell phone object has no attribute manufacturer. Okay, why? Because I made it as private. So anything that you declare as private is not accessible outside the class. I cannot access it outside the class. Okay, so if I want to access it outside the class, I'll have to use a show info method. Okay, again, see, if if I'll try to print the model, will I able to do that? I'll say model here, and herein I'll say iPhone dot price, right? So now model and price are declared public, right? So let's see, let's try to print it and let's see what happens. So herein, again, manufacturer, I'll say iPhone, model, I will say 10, 300, and because I am writing manufacturer before model and price, it is giving me an error. So let me try this. Okay, let me put it out at the last. So again here, I'm gonna say manufacturer, let's say Samsung Note 700. And see, it is printing the model, it is printing the price because they are public. Their accessibility is public, but manufacturer is private. I made it private by using 2 underscores. Okay, remember this init also has 2 underscore. This is also having 2 underscores. So that is why it is showing an error. Okay, so that is how you can hide your data. Okay, now if you want to have access to this data, you can use mutators and assessors, or I can use this show info method. Okay, so what I would do is, instead of doing that, I'll say I'll create object name dot show info. Okay, so I do not have direct access, but I have written a method to access that, right? So let's see, and let's run this again. Okay, now let's see. So enter the manufacturer, and I'm going to enter the manufacturer again as iPhone. Enter the model 10, enter the price 500, and now see I'm able to access it. How? Through this show info method. Okay, and that's how the things work in object-oriented programming. Okay, you hide the implementation details. Why? Again, because if you give the access to your internal system will not be safe, right? And how do we do that? We use private and protected. Okay, now to declare it as private, you use 2 underscore. To declare is that protected, you use 1 underscore. Okay, and whenever you use an underscore, you have to use an underscore here as well in your method. Okay, now protected can be accessed using the subclasses. The difference between private and protected: private cannot be accessed outside the class. Protected can be accessed using the subclasses, which we're going to see in a bit in inheritance. Okay. Now, there is one more method that you can use to access the private data members, and that is called as data mangling, okay, or name mangling. So if you'll see here, okay, name mangling to access private members. So we can directly access private members and protected variables from outside of a class through name mangling. The name mangling is created on an identifier by adding 2 leading underscores and 1 trailing underscore. For example, if you see in this example, okay, salary is a private variable, okay, and it is accessed, okay, it is accessed outside the class by saying the object name dot 1 underscore and then object, the class name and the variable name. I'll just show you here in this example. Okay, so let's say manufacturer is a private variable. Okay, now I want to access it outside the class. Okay, so outside the class, if you do not want to use it through an object, through a method, what I would say is print. Okay, I'll say print, and let's say whatever is the manufacturer, I want to use the manufacturer. So I'll say print the object name, which is iPhone, dot 1 underscore class name, which is cell phone, right? And 2 underscore. Okay, so 1 underscore, 2 underscore, and then the variable name. Okay, let's see. Okay. Something is wrong. Okay, yeah, I used a bracket here. Okay, now let's see. Let's run this. Manufacturer, I'm gonna say it as Samsung. Note, and price is 600. And see, okay, so you can access the private member using name mangling as well. So we call it as name mangling. This is another way, okay? And the proper way which we use in software development is using mutators and accessors, okay? So I'll use mutators and accessors. So if you want to declare the objects of a class, we use, if you want to access the private variables of the class, we use mutators and accessors. Okay, now what is mutators and an accessor? As you can see in this slide, a method that returns a value from a class attribute but does not change it is known as an accessor method. It provides a safe way for code outside the class to retrieve the values of attribute without exposing the attributes in a way that they could be changed by the code outside the method. Okay, let me show you through an implementation, okay, and that would help you understand this. Okay, again, it's the same thing that I showed you through this example. The only thing is, instead of using this function, we are going to use a mutators and accessors. Okay, so you're going to define all the attributes. The way you achieve encapsulation or data hiding is by defining all the attributes as private. Okay, let's understand it with well, we can do it in this example as well, but I just want to write a fresh program so that you don't get confused. Okay, and you have a variety to a program. So let's say I have a class employee. Okay, now I'm gonna write a initializer, that is def underscore underscore init underscore underscore. Again, every method is having a self inside. Let's say an employee has a name and it has a department. Okay, colon, that's the syntax, right? Now I'm going to declare the data members. So how do you declare the data members? Self dot name equals to name and self dot department equals to department. It could be other variables as well. I could have written it as N and D as well. Okay, that would also work. Now, to achieve data hiding, okay, or to make my class safe, what I would do is I'll declare this as private because I do not want anybody to change these values. Okay, now how do you access it outside the class? You use setters and getters. Setters are also called as mutators. Getters are also called as accessors. The way you define it is you write a keyword def, you write set name, again self, and I'm going to write name. Okay, and then herein I'm going to say self dot name, or it is private, so I'm going to say self dot underscore underscore name equals to name. Okay, this is called as mutator. Okay, or other name for this is setters, right? Okay, similarly, to set the values outside of the class for salaries, I'll say set salary. Notice how I'm writing it, okay? I use a set keyword, and after that, I use a name with N capital. Okay, so whenever you have multiple words in the name of a function, the first word is capital. This is called as camel notation, and this is the standard naming convention and the standard practice followed in software industry. Okay, so I'll say in this function set salary self comma, and I'm going to write it as salary. Okay, and herein I'm going to say self dot underscore underscore salary equals to salary. Okay, now similarly, now I'll have getters. So getters is to retrieve the value outside the class. So I'll write getters, which is also called as accessors. Okay, and I'm gonna say def get name. Okay, now get name, and it returns a value. Getters always return a value. So return and self dot underscore underscore name, because it is going to return a name. Okay. Now, because name is a private variable, you need to have a underscore underscore. So again, def, the other getter is get salary. Okay, self. And what is it going to return? It's going to return the salary. It's going to return the salary. So df self, and herein I'm going to say salary. Oh, no, it's not salary. Okay, set name. And okay, what I would do is, okay, I used a department and I have been using salary over here. So it's name, department. So herein as well, I'll say set department. Or what I would do is I'll just say name and salary here. Okay, so name, or let it be department, and herein I'll say set department. Okay, and herein I'll say self dot department equals to department. Well, you can use any variable here, but I'll use a variable, proper variable here. So get name, and herein I'm gonna use get department, right? And herein I'm gonna use underscore underscore self dot underscore underscore department. Okay, so I've made use of getters and setters. Okay, so let's see. So my class is now done. And if you'll notice, every method or every function inside the class is at the same indentation level. Okay, now object you create outside the class. So I will say, I'll create an object of an employee. Let's say emp equals to employee. Okay, and let's say the name of the employee is Tia, and the department is information technology. Okay, now I'm gonna print this information. Okay, so the way you're gonna print is I'm gonna again use f string. You can use the other convention as well. So I'm gonna say name. Okay, and so herein to access the name, you're gonna use an object name. My object name is emp dot. The function name is get name, right? And it will return the name of the employee, right? Slash n, and I'm gonna say department. Okay, and now to return the department, again I'll use the object name dot get department. Okay, so it will return the name and the department of Tia. Now what will happen when you create an object here? This initializer will be called. Okay, so Tia will be the value of this name. Department's value will be information technology. When you write get name, it is going to return the name, that is, it is going to call this function, which is going to return the name, and get department will call this function, which is going to return the department. Okay, again, see what will happen. So program execution starts from line number 17, and herein what happens is the name is Tia, the department is IT or information technology. So herein what will this function do? It will set the name as Tia, and this function will set the department as IT. Okay, what will this function do? It will return this name, and this function will return the department. Okay, let's see. So I'm going to run this code. Okay, and there is an issue here because I did not use this. I'm calling a function, but I forgot to put the parentheses. Okay, let's run this and see here. It is returning the name as Tia, and it is returning the department as information technology. Okay, and that's how the getters and setters work with class. It is a very common and a standard software development practice that when you use classes, you declare the variables as private, and you access them using setters and getters. Okay, So that's about mutators and accessors and data hiding and encapsulation. Now, next one is inheritance. Okay, I'll just give you the concept of inheritance. Okay, inheritance means you can extend a class. Okay, so if you'll see, inheritance allows us to inherit attributes and methods from the base or the parent class. Okay, you would have seen that when you go to your relative's house, the people around you, they say that, oh, you look like your parent, okay, or you look like your mother, or you look like your father, because you have inherited the facial features of your parents in you, right? So inheritance means inheriting the methods and the attributes of one class into another class. The base class is called as a parent class. The other class is called as a child class. Okay. The advantage is, so you can, again, the advantage here is code reusability. Okay. So for example, let's say you are the child of your parent, right? So whatever your parent has, by default, you have access to what your parent has. Let's take it as an example of, let's say when you grow up, you fit into the cloth of your dad's t-shirt. Okay. So you have access to his t-shirt, plus you have access to your own t-shirt as well. You can wear your t-shirt. If you like your dad's t-shirt, you can wear your dad's t-shirt as well. Right. So that is the advantage. Okay. You can reuse the code again and again. Now we have to go into details of inheritance to understand that. Okay. For example, let's say, okay. Okay, let's say I have a class faculty. Okay, so I have a class faculty. Okay. Now what does the faculty has? Faculty has name, comma, age, phone number, etc. Right? Now there are two more types of faculties, right? The faculty could be an adjoint, or let's say visiting faculty, okay, who is not full time. And but in addition to having name, age, and phone, visiting faculty would be paid on hourly rates. Let's assume that. Okay, it might not be like this, but let's assume that. Okay, now full-time faculty. Okay, another is full-time faculty. Right. Now, what does a full-time faculty has? Full-time faculty, other than having name, age, and phone, is paid annually. Okay, or annual salary, or it just have a base salary, right? Okay, the salary rates of visiting and the salary structure of visiting and full-time faculty is different. But what they share in common is the name, age, and phone, and address, and city, etc. Right? So if I create a faculty class, okay, and I extend it in the visiting and full-time faculty class, I can say that visiting faculty, in addition to having access to name, age, and phone, will have its own method, hourly rate. Full-time faculty, in addition to having name, age, and phone, will have its own attribute, that is base salary. So in that case, faculty is the parent class, visiting and full-time faculty is the um, child class. Okay, so once you've written the methods and functions in faculty, visiting and full-time faculty can access those methods. That is the advantage of inheritance. We call it as code reusability. Okay. And the other one is polymorphism. Now, polymorphism means one name, many form. Okay, one name, many forms. For example, water has the state of ice, steam, right, and liquid, right? It has one name. Okay, water is of different forms, ice, steam, and liquid. This kind of concept is called as polymorphism. Again, the advantage is code reusability. There are other advantages as well. Okay, but those basic advantages, code reusability. Okay, and that's about classes and objects and object oriented programming. There are four pillars of object oriented programming: abstraction, encapsulation, inheritance, and polymorphism. We have spoken about abstraction and encapsulation. Inheritance polymorphism is again the advanced concepts which we are going to learn in advanced Python as well. Okay, and that's about classes and objects. Thank you.